So one of the things that we'd like to do in Chapter 2 is we'd like to learn if we have a point or a body, and don't be fooled when I say body or point, it could be anything. When we have a body or point and it's acted upon by forces, okay, we would like to know how to add those forces together. So you're going to hear people in the book, you're going to hear them talk about resultants. Okay? And the first thing that I'd like you to know when you hear the word resultant is just what are they talking about? Well, we're interested in what is the resultant of a bunch of forces. And what that means is we would like to know if I've got 10 forces out there acting on a point, is there a way that I can add them all together and replace them by a single force? So, for instance, if I have a point, a body, an element, whatever you want to call it, and I have, these forces acting on it, 100 pounds this way, 200 pounds that way, 500 pounds this way. Now, of course, I can't. You would really have to know what that way and this way really means if you're really going to figure this out. But I'd like to know how or what force would replace all those forces. So I'd like to know what the resultant is. Now again, since we're talking about a resultant, which is a force, that's going to mean I'm going to need to know how big the force is, and I'm also going to need to know what direction it's in. If it's acting on the body, I assume that we're talking about it's the point of application is the body. But that's what the word resultant means. The word resultant means the sum of all the forces or the replacement for all the forces. And that's going to be an important concept that we want to really get a hold of in Chapter 2, because why do you think that's an important concept? Why do you think finding a resultant is an important concept? Yeah.
Maybe there's some capacity, total capacity number you can hold.
All right, yeah, it could be that. I think there's an easier explanation. If I gave you a list of just numbers, a list of 100 numbers, and I said, hey, I'm going to give you 2 minutes, get your calculators out, and add up these numbers. And you got your calculators out and you're adding them out. How many of you, if I had 5 people in here, how many do you think would get the right answer? Okay? Because you're dealing with 100 numbers. The more forces you're dealing with, it gets a little bit cumbersome sometimes when you're trying to do an analysis. If I could replace those with a single force, it wouldn't be that hard. If I gave you a list of numbers to add up and there was one number and I said add this one up, how many people would get it right? Well, everybody would get it right, I hope. Okay? So that's what a resultant, if we can replace a bunch of forces with one force, it simplifies our life. Yeah?
So is it kind of like an average? Just average?
No, it's the sum of. It's like if this was a scalar quantity and I said 3 plus 4 equals 11, 11 is a replacement for 3 plus 4 plus 4. Now again, we're talking about vectors, so it's not just like that, but it's the same concept. Okay? So Chapter 2 will talk about resultants a lot. Resultants of this type of system, resultants of that type of system, so on and so forth. A resultant is a replacement of a couple forces, 3 forces, 33 forces, it could be whatever. All right, and really that's a big thing. Now, you talked about we could use resultants because,
forget what we say. What did we say? Helps us to look at things or something. And it could, because if I got this body and I know where the resultant is and how big it is, ultimately I'm going to want this body to be in equilibrium. So if I can provide a support in the opposite direction that will hold that resultant, I'll be good. Okay? And we'll talk about equilibrium here in a minute, or later, but that's sort of the concept there. So a resultant is just a force, a single force, that is the sum of, or the replacement of, a series of forces. And right now, here's another thing. We're going to start out, and we're talking about forces that act on a body. What do you notice about these forces? Well, they all act at the same point, right? I show the body as a point. We call that type of force system concurrent. So they have a special name for those types of forces that all act at the same point. And it's called concurrent force system. Okay? And you've seen these force systems before out in the real world. I know you have. Okay? You ever see a bridge truss? I mean, and again, I'll just draw a part of maybe a common bridge truss. You ever seen a bridge truss maybe? And maybe you drove through it. I mean, all these bridge truss pieces, they frame into certain panel points, right? Well, if you look just at that panel point, you've got forces coming in here, there, and wherever, sort of like this. That's a concurrent system. If you see a crane that's lifting something, a lot of times they have spreader beams on them and whatnot, but if you look at the wires and stuff, hey, they all sort of come into the same point, don't they? So a concurrent system just means, hey, everything acts at a point. Okay?